The following presentation of the Virtual Anticipation Network, VANE, is brought to you by BigBear.ai in conjunction with the Irregular Warfare Technical Support Directorate. This video demonstration highlights the capabilities and functions of VANE as a predictive and prescriptive analytics tool. The overview summarizes what VANE can do for the user. VANE provides whole-of-the-environment situation awareness and course-of-action analysis across a plethora of domains, echelons, and use cases. BigBear brings lots of data to the table from over 100,000 traditional news sources and social media platforms, including Twitter, VK, and Sina Weibo. High-level strategical data sets include but are not limited to global events data from GDEL, the World Health Organization, and the IMF for economic indicators. BigBear brings data across the different PMISI domains for the user to take advantage of in their forecasting. The power of the capability comes when a user integrates high-fidelity owned data with BigBear's multi-domain data and runs it through VANE's forecasting algorithm. BigBear's forecasting algorithm is called tensor completion, which is represented in the bottom of this diagram in the inductive machine learning forecast. What's unique about tensor completion is it is a purely inductive everything predicts everything forecast of the future. It takes all of the data fed into the system, it backcasts or fills historic gaps, learns all of the relationships about the environment, and then uses those relationships to intelligently forecast what the future holds for the user. With the backcasting, tensor completion enables VANE to take advantage of all of the data that the user brings to the system. In the IC intelligence community and DoD Department of Defense, dirty data is a very real problem. Adversaries are intentionally obfuscating data. There may also be sensors that may or may not have been pointed in the right direction. Tensor completion enables VANE to fill those gaps, whether there are many gaps or just a few gaps, and then leverage that data in the forecasting where traditional data science methods may exclude that data for our forecast. The diagram on the right highlights how users leverage the capability and derive insights from the data provided in the algorithm produced. First step is analyze. This is a whole of environment situational awareness. With tensor completion, VANE can now forecast what's going to happen a day from now, a week from now, a month from now in the user's environment, allowing users to understand and dig into those forecasts and relationships that were learned about the environment. The second step is alert. In traditional alerting, receiving new data today that's different than expected is typically followed by a reactive response. In VANE, predicting an event is going to occur a week from now allows the user to understand what the future holds and that it looks a little bit different, allowing the user to switch from the reactive footing to a proactive footing. The third step is respond. Knowing an event is going to occur perhaps requires taking steps to prevent the event from occurring, or maybe the need to take steps to take advantage of the perceived event. These actions can be accomplished in VANE's intuitive UI. It is a self-service, on-demand scenario forecasting capability in which the user can ask, if I make this decision, what will be the impact? Will I achieve my goal? Will there be unintended consequences? Multiple what-if scenarios can be executed side by side to help provide decision support to achieve the desired outcome. The final step is assess. VANE's tensor completion, an automated workflow, run the data every time new data is received into the system through live connections. Whether it be daily or weekly or monthly, when the data flows into the system, all of the models and algorithms are being rerun. VANE takes the new data item, compares it to the forecasted data item, and uses that added information to reforecast the future, retrigger any alerts, and rerun all user courses of action such that every time the user steps into the tool, the insights are as up to date as the data itself. This process allows the user to track if a goal is closer or further from achievement as the world keeps turning. The Virtual Anticipation Network, VANE, is a web-based application best accessed on a Google Chrome browser. The infrastructure is hosted on BigBear's commercial AWS account and is accessed via a user's unclassified network connection. Future plans include an on-premise air-gapped version of this capability ready for deployment at the beginning of 2023. In addition, we are expecting our IL5 ATO also at the beginning of 2023. The VANE system is API-centric and microservices enabled, allowing many ways to access the application, the UI, the data, or the machine learning functionality. At BigBear, we've been able to take bits and pieces of the infrastructure and take out the modeling guts and bring them up to the Secret Internet Protocol Router Network, or SIPR, for a customer. For another customer, we've been able to take the whole application itself and deploy it in a controlled unclassified information, or CUI cloud. This is the data page. As an analyst, I've stepped into the application and I've created the data. the environment that I'm interested in. I went into the UI, I clicked and dragged data pieces, and I pushed a button. Pushing that button caused the model to run on demand behind the scenes. Our machine spun up, gathered the data, co-located it, transformed it, trained it, tested it, validated it, and then provided the results back into the user interface. This data page is a descriptive analytics page that lets the user explore the data they brought into the model. I'm going to look at a Southeast Asian country model. As an analyst, given the events that are happening in Russia and Ukraine, I'm interested in looking at the long term strategic outlook of the South China Sea region to see if China will be emboldened by the events in Russia and start turning on Taiwan. So, from this page, right away we can see that I have 51 different data items and 13,000 data points in this model. The data comes from 9 of those sources. If I scroll down the page a bit, what you'll see is here we have the World Bank data source, and if I pop this open, I can see all of the data with the description that I chose to include in the model. Here you can also see I have GDELT data and IMF data in this model. On the left hand side, we can see the data items themselves. I'm going to pick Armed Forces personnel, and now I can see this map auto-populates and shows me the country area that I have selected for the model. What this model is going to do is for every data item and for every country I've selected, it's going to predict the data item for the next 60 months. It's going to give me a long-term outlook for everything in this environment for the next 5 years. Now, this is a high-level strategic use case. We have had success predicting on military bases or military units, so a non-geospatial entity. We've also done more operational use cases. We were able to use air tracks and sea tracks to predict military show of force using MGRS grid squares. This tool is very configurable. A no-code change to adapt to any numerical based time series data that a client has and would like to predict on. Now we are going to explore the driver's page. The driver's page explains to the user what the model has learned about the environment. One of the benefits of using tensor completion again is that it is explainable. The relationships that are learned in the environment can be portrayed and shown to the user, which helps in that decision-making process. If I have the power to affect a change in a data item or invested in seeing an outcome in a particular data item, I can peel back the layers of relationships and find more than one way to achieve my goal. I have chosen arms exports. What this is showing me in this Sankey diagram is the most influential measures that drive changes in my data item of interest. What I can see here is that foreign direct investment, armed forces personnel, and arms imports are the top drivers of change in arms exports, my value of interest. Now, one of these makes a lot of sense to me. If somebody in the region is importing arms, it makes sense that it's related with someone in the region exporting arms. Let's circle back to that inductive machine learning that we talked about before. As a user, I did not tag independent or dependent variables. The model has no understanding of the semantic meaning of the title. It's only looking at the data. So, the relationships that are exposed are those that exist. I can learn things that may surprise me. It can confirm my preconceived notions, or it can let me know that there's not a proven data relationship between the items I believe were related. We're going to draw out this diagram to a depth of 5 and a top 5 per node to show that we are not learning one or two relationships about the environment. We're learning many very nuanced relationships about how the world works. As you can see, the UI becomes a little crowded, but this is to illustrate the point that the model is truly learning everything about the environment to give you that situational awareness. I'm going to bring this back down to a depth of 2 and a top 3 per node, and I'm going to flip this around. Now I'm looking at ARMS exports as the driver and understanding what does ARMS exports drive changes in. So, if I'm in a position of power to affect a change in the number of ARMS exports in the region, here are the dominoes that I'm going to see after that. If there's a change in ARMS exports, there will then be a change in death by assault and a change in the presence of peacekeepers, and downstream from that, a change in GDP. This is showing me if I make a decision that impacts arms exports, here are the things I can expect to see happen after that. Now, let's look at a forecast. I'm going to choose Armed Forces personnel in China, and as you can see here, here's my time series forecast. The solid green line is the data we were able to gather from the source. The dotted green line is the forecast. If I hover over this, I can see that out in 2025, we are predicting 2.47 million armed forces personnel in China with an error rate of 3.2%. You can see in the visualization, we give you an error fan chart to see the other possible values for this data item. I'm going to choose fight events from China, and here we can see the forecast for this data element. Tensor completion is forecasting all of the data items at the same time, so I can choose any data item from the measure filter or any entity from the country filter and see the forecast in real time. On the left-hand side, we have the various baselines. As previously mentioned, every time we get new data, a new forecast is being run. I can go back a year ago to last July and see what the forecast looked like at that point in time. As I click forward, you can see that the forecast changes as the solid line as the actual data is learned, and we are adjusting our forecast based on the current events in the world. The last thing I want to highlight about the tensor completion algorithm is the backcasting. If I go to ARMS exports from Indonesia, we get a good visualization of a data set that is very gap riddled. The solid line is the data we were able to gather from the source. There are 4 one-year gaps and 1 5-year gap. Traditional data science would have to throw this data out. When I turn on the inference trace, we can see tensor completion intelligently fill those gaps. It didn't provide a single value, it didn't play connect the dots. Between 2010 and 2015, you can see that it predicted an interesting peak dip peak behavior. This just illustrates the power of tensor completion to enable us to use all of the data in our forecast. Now we're going to look at the scenarios page, and this is that self-service course of action analysis. VANE enables the user to ask 2 types of question. The first question is, how likely is it that my outcome of interest occurs? I'm going to open this scenario configuration, and in this scenario, I'm asking, how likely is it that we see an increased level of diplomatic cooperation out of Vietnam out at the end of 2023? The solid line is the data we gather from the source. The dotted line is the forecast, and this red dot is my criteria point. I want to know how likely it is that I see that dotted line come over my criteria point, that I see the increased engagement. The results here show me the overall likelihood of my scenario occurring. We can see that in January of this year, it was extremely likely that my outcome of interest occurred. However, in July, we're only about 50% likely that my outcome of interest occurs. So, what I can do as an analyst is look back at how the world looked, what the environment was back in January that made my outcome of interest likely to occur. Over here, we can see the overall likelihood drivers. The way you can interpret this is I'm learning which entities are most influential in my outcome of interest. What I can see is that Indonesia, Singapore, and Thailand are most responsible for the level of diplomatic cooperation in Vietnam. This is very interesting. This is telling me that rather than engage directly with Vietnam, rather than engage directly with the target, there are other actors, other entities I can engage with to achieve the same goal. If I go upstream, I see Australia. This tells me I could engage with Australia that will have that ripple that will then result in the level of increased Vietnamese engagement I'd like to see. We can do a similar analysis with the measures. What this is telling me is that the top influencers on my outcome of interest are Goldstein score, which is a level of instability, exhibit forced posture, and use of unconventional mass violence. So rather than send my State Department to Vietnam to engage diplomatically, perhaps I can deploy my international peacekeepers to the region to decrease the use of unconventional mass violence, which will then result in the increased level of cooperation from Vietnam that I'd like to see. This is giving me a roadmap on how I can achieve the outcome that I'm interested in. The other type of scenario is impact. An impact scenario enables us to pull different levers and say, if I made this decision, or if the adversary performed this action, what would the impact be in the environment? On the left-hand side, you can see all of the scenarios that I have. There's no limit to how complex these scenarios can be, and there's no limit to how many you can bake off at the same time to really test out all of the possible decisions and find the most optimal course of action. In this scenario configuration, I'm asking if these smaller nations in the South China Sea region increase their military presence, how will China react? What would the impact be for China? I'm going to open this measure configuration, and again, the solid line is data we gathered from the source. The dotted line is the forecast, and the red line is the criteria point, the decision. What if Japan slowly increases their armed forces personnel instead of the forecasted decrease? I have repeated this pattern for the other nations that I've selected, so a small increase in armed forces personnel in the Philippines, Singapore, South Korea, and Vietnam. These are the results. Right here, I can see the data in my environment that was most impacted by the decision that was made. A red coloration is an indication of a negative numerical change, and blue and above the line is a positive numerical change. What I can see as the most drastic impact is a significant decrease in the presence of peacekeepers in the region. Immediately, I could recognize that as a negative impact, perhaps an unintended consequence of the increase of military presence. I can also focus this on a particular country. I am going to choose China. Now I can see in the impact chart that there will be more imports and exports from China. Also, more fight events and assault events. So now I am narrowing my lens to see what the impact is for a particular actor. I can also choose a particular data item. I am going to choose Armed Forces personnel to see if China will respond in like. What I can see in this impact by time chart is that China is going to respond by also increasing their regional forces as well. They will have approximately zero point 0.1 million more armed forces personnel given the decisions that were made. That is the impact of the scenario. Thank you for watching this presentation of the Virtual Anticipation Network, VANE. For more information, contact Samantha Hamilton at samantha.hamilton@bigbear.ai.